The function f of t equals 40,000 times 2 raised to the t over 790 gives the number of bacteria in a population t minutes after an initial observation. How much time in minutes does it take for the number of bacteria in the population to double? So we have this function f of t equals 40,000 times 2 raised to the t over 790. And we need to find out how much time, or minutes, t, it takes for the value of f of t to double. So we can look at the base of the exponential here and see that the base equals 2. And that means that every time the exponent of the base here increases by 1, the value of f of t doubles. Because think about it, if we have 40,000 times 2 raised to the 1, then that's just 40,000 times 2, which is 80,000. And then when the exponent of the base 2 goes up by 1, so meaning it goes from 1 to 2, then 2 raised to the 2, that's just 2 times 2, so that means the second 2 doubles it. So this will just be equal to 4 times 40,000, so this is 160,000. And the same thing when the exponent goes up by 1 again. So when we have 3, then it's 2 times 2 times 2, and that last 2 will double it from the previous 2 times 2. So then this would be 320,000. So the doubling time, the amount of time, the minutes it takes for this function f of t to double, is whenever the exponent increases by 1. And we see that the exponent here is t over 790. So when t equals 790, we have 790 over 790. And then when t increases by 790 again, we get 1,580. And that divided by 790 is just equal to 2. So every time the value of t increases by 790, because we're dividing by 790, every time we add 790 to the numerator, we're adding another multiple of 790. So then that causes the exponent to increase by 1. And when the exponent increases by 1, the value of f of t, the amount of bacteria, doubles. So that means that we need t equals 790 minutes for the population to double. So B is the correct answer.